There we go. It says that I'm live. Hello and welcome to Waterloo Public Library's Maketastic 3D printing program. My name's Jamis. I am a programmer with Waterloo Public Library. I've been around for about 5 years. I run programs for adults and children. I have a focus on teaching people how to use technology. For today's program, we're streaming this live, and it's also going to be recorded for posterity so that you can come back and watch it at a later time. The major advantage to it streaming live is that it's connected to YouTube, the Waterloo Public Library YouTube and Facebook's accounts, and you can ask questions live. I have a whole comments tab here, so if you are watching this broadcast and you have a question about anything along the way, feel free to fire it into the live chat for the YouTube or Facebook pages, and I will try to keep an eye on the comments and answer any questions that you may have along the way. So today we're going to do a little bit of introduction to 3D printing. There are basically three major topics that I want to talk about. First is how to find, modify, or create a design for 3D printing. Multiple pathways and methods to do this, some more technically advanced than others, but overall not terribly difficult. Step number 2 with 3D printing, so after you have your design, you're going to have to put it through what's called a slicer and turn it into G-code. So a slicer is a piece of software that can take various 3D design model files and turn it into code that a 3D printer can use. Now, it isn't always a straight up simple thing. You know, it isn't just drag and drop, take your model, put it in the slicer, and it spits out something. You have to enter certain variables and things. You have to specify what sort of material you're printing with, and we'll talk about that as well too. You also have to specify what sort of machine you're using, because different machines have different abilities. The biggest, most common difference is the working area, so how much room it has to work and print within. So things like that. You have to specify a bunch of variables. And so once you've put your design that you've either created or modified or just found, you can buy them or just download free ones online. Once you have that design, you put it through the slicer software. Last thing you're going to want to do is print it. Arguably, it's probably the easiest part of the process now. 3D printers have come a very, very long way in the past 10 years. They are a lot of the machines are more literal, just drag and drop. You just put your file in and you tell it to go. Handling issues. So every once in a while, a 3D printer will not function properly. Things won't work out for whatever reason. And you'll have to be able to diagnose and fix it. And possibly alter your design or alter the parameters you put in for your slicer in order to get a functional 3D print. Once in a while, you just have to run the 3D print again and it works. I've experienced that myself. It's an inexact science sometimes, but yeah, those are the 3 steps. So we're going to talk more now about finding or modifying or creating your own 3D model design. So I'm just going to share my screen here. Put it on. I want to share my web browser. So I have all tabs set up here for us to discuss. There we go. A bit of an inception thing going on. So first up, we want to find or modify or create our own design. Finding them is pretty easy. There's a few sites nowadays that have been set up around sharing 3D design files. This one in particular that I have up right now is called Thingiverse. It used to be a pretty awesome site, then it got bought by a company and hasn't been that great lately. But Thingiverse shows you tons and tons of 3D design files that have been designed by people, and you can download them and print them yourself. Just scrolling through here, these are some of the ones featured on the main page. Like we have a really cool switch you can print and put over top of your light switch and So it looks like this really neat geared thing. Come on, load up. There we go. You may notice this is a 3D printed design. It looks kind of like wood. And that's actually a material you can print with. There is wood filament for 3D printers that have a look and texture like wood. You can even sand them like wood. You can stain them like wood. They're pretty neat. But we'll talk a little bit more about that a little bit later. So like I said, Thingiverse is one of many sites where people have designed and shared their files. And so you can pick just about anything that you like here. You can search, and then you can 3D print a file that you see. Here's another one. Bottle cap opener / shooter. Scroll down. Let's wait for it to load a second. I think the streaming has slowed down the internet. So yeah, so this takes the bottle cap off, and then we'll shoot it out. So say you wanted to 3D print this, you'd have to go and find the thing files, and down here it has downloads. Looks like there's a few versions. They have a version 8 and a version 9. So these are what's called STL files. It's one of the two major file types that people use when creating 3D designs that they want to print. The other one is OBJ. There's a third new one that's coming that has copyright protection and stuff like that. And then I can't remember the ending file name for it off the top of my head right now, but I can see that becoming very popular in the near future, because then creators can control whether or not people, or what people can do with their files. Right now, you can literally download this and print it off as many times as you want. You can download this and modify it and print it off as many times as you want. We'll talk a little bit more about that as well too. So Thingiverse is a very popular site for sharing and finding 3D printed files. Another popular one I just wanted to highlight is this one called Yegi. It's an aggregator site, so it has a program, a robot that crawls the web and looks for these things, looks for these files to link to. So some of these 3D design files, when you click on it, it's kind of like Pinterest. It may take you to a website where you can download it straight off the internet, or it may take you to a website where they'll ask you to buy it. All right, so not everything that you're going to see on Yegi may necessarily be free, but like some really intricate designs, like people make like whole 3D design RC cars and trains and stuff like that, all sorts of crazy things. And again, it has a search, a very robust search that lets you look up all sorts of things. A very popular thing for people to do are movie props. Like you can literally print Iron Man armor. And here's a bunch of models. Ring. There we go. Iron Man Mark 50. Let's see if it'll load up. So again, this is very popular amongst model making community and movie prop community. You can make all sorts of movie props. Oh, nope, it didn't like it. Or did it open it? I didn't like that. No, it doesn't look like the link is working right now. So it's a little bit hit and miss. There we go. You have a Mark 42 Iron Man helmet. All sorts of neat things you can print. So that's the first major method for 3D printing, is finding something someone else has designed online, downloading it, and printing it yourself. The other two methods that I mentioned, modify or create a design. There's a website called TinkerCAD, which is fantastic for introductory 3D design. There's all sorts of 3D design software out there, but TinkerCAD is by far the best to use when you're just getting started. So it shows, a few design files that are up here. I have my TinkerCAD account open. And so these are some of my more recent projects that I have been working on. This one in particular, I'll click on it, was a battery clip mount for a little model robot that I was making with my youngest son. I'll open it. Hopefully we'll have more luck opening this than we did the Iron Man. There we go. So in TinkerCAD, it gives you this work plane, this blue surface to to work with. And we have this cube over on the left that lets us navigate a little bit, lets us turn things around. So these here were a pair of clips that my son and I designed for his little robot. I'm going to pull it out and have it here. So we purchased a little model robot project for us to build together. And with this model robot project, there was no battery. You had to go out and buy your own battery. And they recommend buying one of those small backup battery banks that you can get from like the dollar store. So we found a nice one. We bought it. It was fairly inexpensive. Brought it home. But the clips that came with the model robot kit, I'll show you here, are circular. They're meant for a round backup battery system. So we just took some careful measurements of our battery backup bank here, a rectangular one, and we created this model file in TinkerCAD. It took us all of 15 minutes to create this little model, and then we downloaded it and put it through our slicer, 3D printed it, and 20 minutes later we had battery mounts that fit perfectly on this power bank that we had purchased. And like really 20 minutes of effort, and we were able to come up with an add-on that increased the functionality or the use of his little model robot. Pretty neat application right there. There's lots of little projects and things around the house that we end up doing. Let's see if I can go the right one. We're going to go back. Another one I wanted to highlight was, let's go back again, doorbell cover. So my doorbell cover fell off and broke some time ago. And I went to go look to buy a new one, and they were ridiculously expensive, like $40, $50 for a new doorbell cover. It was just almost the price of a new doorbell, and our doorbell worked just fine. So again, we fired up TinkerCAD very quickly. I created this model file. It's just basically a box without a top, and then some slats for the sound to travel out through. These are about the same location as the chimes are on our doorbell. Printed this out. Now this was a little bit longer print. I think it left it go for like 7 or 8 hours to print this whole thing. As you can see, it's a lot larger on this work plane than those little clips that we had for my son's robot. Printed it 7 or 8 hours later. We had a doorbell cover. Just literally took it off the 3D printer and hung it up over the doorbell, and it fit perfectly. And again, we just took very accurate measurements and made sure everything was the right dimensions. Measure twice, print once, and it all worked out. And we now have a new doorbell cover. It was probably about, aside from the 7 or 8 hours of printing, I would guess is about $3 or $4 in plastic and filament that the 3D printer used. So again, a heck of a lot cheaper. It just took a little bit of time. Most of that time you walk away and let it do its own thing. So what we're going to do, I'm going to demonstrate really quickly making an object. Now this is not, this course, this stream is not meant necessarily to teach you how to use TinkerCAD. And like I alluded to before, there are many other options out there. So I'm going to click Create a New Design. There's 3D modeling software like SolidWorks or Blender, which you can use to create 3D printable files. Those ones are multi-week courses. You can take whole college classes on using those programs. But here in TinkerCAD, I have a nice blank work plane, and it gives me a bunch of objects to start with, to work with. Some more complicated than others. But for the vast majority of the stuff that I do, I'd say you're using the cylinder or the box. I also have text as well too. We sometimes use text. Cones sometimes used, because the kids and I design model rockets sometimes. The paraboloid is another popular one. They can take our objects, drag them over onto the work plane here. We just put onto a cube. So literally we could download this cube and print it on a 3D printer, but you can do a lot more than just deal with the cube. Cube, you have all sorts of control. So I just clicked on one of these little black dots on the bottom on the work plane, and it gives us a measurement here. This is currently set to millimeters. Everything's in millimeters right now. So this is a 20 millimeter cube. So 2 centimeters, 2 centimeters by 2 centimeters by 2 centimeters. You can literally type in this box and make it a different size. We can make it 4 centimeters or 40 millimeters, and it will change accordingly. You don't necessarily need to type those numbers in. That's only if you want a lot of precision. You can click on these little white squares and drag, and it'll change those dimensions. You can only change 2 dimensions at a time, like this. We can then increase the height or depth depending upon how you're looking at things. You can also move this up off the work plane. Now, this isn't good for 3D printing because when you 3D print, you have to start on the flat surface. But if you want to create something with overhangs and things like that, you need to lift things up. And so this gives you the ability to lift things up as well, too. You may notice here there are 2 major options, solid or hole. You could actually turn this into a hole, and it becomes kind of transparent, see-through. I'm going to leave it solid for now, but I'm going to show you how to work with a hole real quick. I'm going to take this cylinder and drag on the work plane. Now, this cylinder by default is already set up to be a hole. I'm going to make it bigger, and then I'm going to drag it into my rectangle here. There we go. So what we've just done is we've created a circular hole through the rectangle. And we just have to select both items. We hit group up here. It's going to merge them together. And it basically just made that cylinder disappear. But in the process of it disappearing, punched a hole right through our rectangular box that we have here. Right? And we can drag this back. Hold on here. We can drag this. No, wrong one. It's a lot easier to do this with a mouse. You can drag this back down to the ground. 0. There we go. So we could literally 3D print this little thing right here. So in terms of 3D design, it's very much an iterative process. So you make one thing, you add or make a change to it, you make sure things are right, and then you move on and add more, right? So this could be just the beginning of a much larger, more complicated project, right? We can rotate this object. So we click on here on this little bendy arrow. We're going to try to make it 90 degrees. And then we're going to pull it back up since it sank down into the ground. Pull it back up to the surface. There we go. We have a rectangle with a hole in the side. This could be something like an axle holder. Maybe you're making a little car and you need an axle to run through and you need something to hang on to it. So this is the start. If you have an axle holder, you're probably going to need 2. So we're going to hit Control-C, Control-V. Now we got 2. We just want to make sure we keep them lined up. We can separate them a little bit. There we go. So we have an axle holder for an object, or say our car. Then we're going to need to keep these together somehow. So let's pull over another box. I don't really need to make a car. I'm just trying to demonstrate how you do it. And normally you'd be a little bit more precise with your measurements. I'm just kind of winging it right now. There we go. So say we wanted an axle holder, we just made one for the bottom of the car. We just started making it, okay? Now these are 3 separate objects, so again, we just got to highlight everything, hit merge, and it's made into one big solid object. Right? We can give it a name. We'll call it holder. There we go. Oh, say you have your 3D design. You've downloaded it or you've created it yourself. Now we are going to have to put it through a slicer. Just going to take a moment, and what we're going to do is we're going to hit export right now. So we're going to download it. Oh, there we go. So it shows us now the major file types. We have the OBJ, the STL, and this one, the GLTF or GLB. This is the newer one that's probably going to be very popular soon. I usually just work with STL for no other reason than it's the file type that I have used forever and ever. And you can see it has downloaded. So the STL file, the 3D design file for my little axle holder has been downloaded to my computer. I'm going to stop sharing that. There we go. So there we go. So we either found, modified, or created a design, and we just downloaded it. So the next thing we're going to have to do is put it through our slicer and turn it into G-code. So for that one, I'm going to have to share another screen. I think we stopped that. We're going to share a new screen. Give me 1 second. There we go. Oh, I left my sample up. Hold on, I'm just going to complete that. So, next part, like I mentioned, we're going to have to use a slicer. So we have here a slicer. So this is a set of software that can take 3D printed files and turn it into something that your 3D printer can use. A very popular one, and again, you don't have to use this if you don't want to. There's many other options out there, but a popular one is called Cura. It's produced by a company called Ultimaker, who also produces their own 3D printers. So when you use a slicer, basically it gives you a little model of your 3D printer. So right here, this little box, the bounded area, even shows the springs and the platform. This is a small model of a portion of my 3D printer. And what I need to do is to open up that little file that I downloaded, Axle Holder, and then pops into my 3D printer. So this is a virtual version of my 3D print. Now here it says slice. This is the button you press to turn it into G-code. Now if your settings are all fine, you're happy with them, if you did them in advance, you could just do that. But we're going to talk a little bit more about the other settings in this 3D printing software. So in Cura, you can specify what sort of 3D printer you're using. Right now I have highlighted Wanhao Duplicator i3 Plus. You can add different printers, so it has some preset profiles. So if you have a different make and model of 3D printer and they've had a profile created for Cura, you can just add that. You can also set your own profile. So there are some hardcore people out there who have made their own 3D printers. I have two that I made, or at least what's left of them. I have a commercial one that I use now for most of my 3D printing. And you can specify your own parameters. You can make your own 3D printer. Actually, isn't terribly difficult. No, that's not true. It is difficult. There's a lot of things to track, but it's attainable. It's something that a lot of people with some sort of mechanical inclination can do themselves. So you can set your own profile. You can create your own profile for your own 3D printer, and you just have to know the variables. You have to know, the area that it's working with, so how far it can move in the X, Y, and Z axes, how fast the stepper motors can turn, how many steps they do per how many degrees each step takes as it rotates, and things like that. You have to know information about your hot end and how big it is and all that stuff. It's a little bit crazy and a lot more things to worry about. It's a lot easier buying it and then just specifying your profile. So here I specified my profile. The next thing you need to specify is the material. So there are a ton of different materials you can print with on 3D printers. And you click on this drop down and it shows you all sorts. These are different companies, but it's saying generic ABS, CPE, HIPS, nylon, PETG, PLA. PLA and ABS are by far the most popular ones. We'll talk about them a little bit. PLA stands for polylactic acid. It is a biodegradable, semi-food safe. It's not recommended by the Food and Drug Administration, but it is fairly safe, fairly benign. It's made from corn products, usually. You can make your own polylactic acid plastic. It's actually milk plastic. So you could take milk and you add a little vinegar and it creates little clumps that you can squish together with your hand. It's actually an activity that I've done with kids before. That's polylactic acid plastic that you just made straight from milk. So we're going to specify PLA because that's the stuff that I have in my 3D printer here. And then you can specify your print settings. So basically how high you want each layer to be. So right now it's set to 1/10 of a millimeter, which is pretty fine. It can go a little bit lower than that. It can go down to 6/100th of a millimeter at a time. The big thing to be concerned about when you're specifying all this stuff is that it will affect how long it takes for the print to run. So the more fine you put it, the longer it'll take for the 3D printer to print, because it'll have to print more layers, right? It can only move, the machine can only move so fast. Same thing for this other factor here that you can specify in your slicer, the infill. So a 3D printed object, usually you don't print them to be 100% solid, although you can. That is an option up here. You can specify, I think I right-clicked by accident. Hold on. There we go. You can specify 100%, so it'll just print out a totally solid object. Usually you only do about 20%. For the vast majority of applications, even under some mild loads, 20% is more than enough. What it does is, as it 3D prints, it prints several shells on the outside. It's like usually 2 or 3 shells, solid shells on the outside. And then on the inside, it will print a honeycomb pattern. And depending upon the percentage of infill you specify, it will dictate how big or small that honeycomb pattern is. And it gives it quite a bit of strength. 20% is fantastic for the vast majority of 3D prints. Support is another one that you need to be concerned about, and that's actually the one that we need to be concerned about with this axle holder. So a nice square cube wouldn't need any support because it is a square cube. It doesn't have any overhang. Overhang is when you have a part that is not supported by anything underneath. So on my axle, hold on here. Let's see, well, let me turn this. I want to move this. No, it's not letting me. Can I do this? There we go. So on my axle holder here, in the circles, these holes have no support. Now, because it's a circle, as the 3D printer prints, it prints up layers at a time from the bottom up. Really thin layers. It could probably build enough support with the circle as it builds up one layer at a time that you don't need to worry about support. But if it's a really big circle or an odd shape, or if it was like a really square, long, narrow shape, you're still going to want to put in some form of support. So this basically generates these little structures that will support overhanging components on your 3D print. And to do that, it basically prints another honeycomb structure, but it's something that you can pop off afterwards. The sole purpose of this honeycomb structure is to support something that will have an overhang that would normally just fall if the 3D printer squirted out the plastic and there was nothing there to hold it up. So you would use support. So, we could specify supports for this just to make sure that our circles will come out nice and circular and everything will be good. And then the last thing is adhesion. So this adds a little bit of extra plastic to the print on the bottom. There's different kinds of adhesion, rim, raft, and skirt. Try to merge all those into one word. A skirt, I believe, is the one where it's this extra plastic that just gets added in a layer spreading out from your 3D print. It's just to help make it stick to the platform. It's one of the common pitfalls with 3D printing when the physical printer is printing. The bed that it prints onto is a little bit warm. It's a little bit heated to help keep the plastic from shrinking. So what will happen is it will squirt out this plastic. It'll be warm. And if it didn't have a heated bed, if it didn't have a heated platform that it printed onto, that first few layers would eventually start to cool. They would deform, they would shrink, and your 3D print can actually pop off your platform. So that's usually fixed by having a warmer platform. You have different temperatures depending upon the plastic, and so your 3D printer will heat up its platform to a specified temperature to help keep the plastic stuck on there. But even then, depending upon your platform and the material that it uses, that doesn't always work. So adding something like a skirt can help. It also helps if you're printing more than one object at the time, which you can do with 3D printers. Right here, in my example, I only have this one axle holder, but in theory, I could print more axle holders, or I could print other parts. Like say you're printing a large project that has multiple pieces to it, you could print all of them at the same time, so long as they all fit on this platform separately. And the skirt is a nice way to try to keep things separate. It's also a good way to help ensure that everything works out, because you could have, say, 10 different objects being printed, and if just one of them falls off or doesn't adhere or whatever, some error or issue happens, and it can all of a sudden start rolling around and get in the way of the other 9 things, and those things can all get wrecked as well too. So it's just another way to add a little bit of extra insurance or protection to your 3D print when you're doing more than one thing at a time. I just talked a lot about slicing. So I think ours is all good right here. Make it a little bit quicker. Instead of it being 0.1, we'll do 0.2 millimeters. All right. So I think we're okay with these settings. And what we're going to do now is we're going to hit slice. And so it'll take a little bit of time. The software does its thing. And it gives us an estimate here. So it says it's guessing it's going to take about 5 hours, 43 minutes. It's going to use 86 grams or 28.99 meters of filament. This is a great way to make sure that you have enough filament for your prints. Time one isn't always very accurate. Smaller prints is usually more accurate. Longer prints, I find it can be up to anywhere from 20 to 50% longer than its estimated time. But this is just to give you an idea, a rough idea as to how long it's going to take to print. 3D printing is one of those things where you can walk away, but it's still recommended that you come back and check on your print once in a while just to make sure things are going okay. Because if nothing else happens, if there's like an error and it's not printing out properly, you can at least stop the print and salvage your plastic, right? But you can come back every once in a while and take a look and see how things are going. This is also something that you can tweak as well too. Say you belong to like a makerspace or you've gone to a library to use their 3D printer and they have booked times, and you only have certain windows of time to work with. You can tweak your 3D print. You can tweak it in the slicing software to try to get variables in there that you're happy with, but make it fit within that time frame. It's another advantage to having these estimates. It also helps with billing some places too. There are online places where you can send your 3D print. You can send your file off to be printed, and they will charge by weight and of the weight of the plastic, or by the length of time it takes for the print, or sometimes by a factor of both. And this way you can get an idea as to how much this print is going to cost you if you're really set on paying somebody else to do it for you. So what we do now, now that it's sliced it, we're happy with it. We're not going to change anything. We're going to hit. Well, actually, I have an SD card here. My 3D printer uses SD cards. I'm going to throw it in my computer, and I'm going to download. Yes, there's a problem with this drive, but it still works. There we go. It says it automatically changed save to removable device. 3D printers, a lot of them nowadays use SD cards. It was a very common problem in the olden days, probably about 5 years ago. With 3D printers, you'd have to connect a cable from your computer to your 3D printer to send the file over for it to print. And if something happens with your computer, something happens to your printer, something happens to the cable in between, your 3D print could be ruined. So nowadays, it's very common. It gets saved to a SD card. There we go. File saved. It gets saved to an SD card so that you don't have to rely on the computer, or at least takes out the computer and the cable portion of what can go wrong. So what we're going to do, we saved it. I just need to eject my SD card. There we go, got it ejected. So we have designed a file. We want to 3D print the file now. We've already put it through our slicer. And so now we're going to move on to the physical part, printing it. So I'm going to change the camera angle a little bit. So I apologize if I make anyone seasick. You can see more of my messy work. So in the background, I have my 3D printer. So this is the standard setup of 3D printer here is what's called an i3 variation. 3D printers have been around for a while. About the 70s is when they were first invented, and commercial units were produced in the 80s. They were very large beasts at first, just to get something with this sort of print volume working on it. They were like the size of like an industrial washing machine. They were just massive, massive boxes. And then around 2005, there's a gentleman, I can't remember his name for the life of me, out of Britain, started up what's called the RepRap project. The whole point of this project is to try to create a 3D printer that people can share and modify that can print copies of itself. Now, it's way off before that technology is going to come to fruition, but it got a lot of people interested in 3D printing and 3D printing at home, because he shared all the files and all the designs for free and open on the internet. And so there were hundreds, if not thousands, of people all around the world making their own 3D printers. And this sort of setup is kind of what people ended up gravitating towards. This is a very popular, very stable, very easy to put together setup. And so it's very common to see this style out there when you're looking at commercial 3D printers, or you're looking at ones that you can build yourself. It has this nice big box on top of another box on the bottom. We have a platform here. This platform, as I mentioned before, can heat up. You can specify in your slicer software and things like that, depending upon the material that you're using, what temperature to keep it at. For PLA, polylactic acid, it's about 60 degrees Celsius. So when you put in your SD card and you tell it to go print, it spends a little bit of time warming up, and this gets up to 60 degrees. This platform can move forwards and backwards. Just be a little bit gentle with it. You can see how it goes. It has a little stop switch, a micro stop switch. So when it starts up, this platform will slide back until it hits the switch, and it knows that it's at its limit, and it knows it has 200 millimeters to work with moving forward. Next axis, we have a Y. So we have the X here, we have the Y here. So the printing head, so this is where the plastic comes out of, can move back and forth like this. And then finally, the Z axis can move up and down. That I can't do on my own. There's actually two motors on screws that will move this whole thing up and down. So that's basically how a 3D printer moves around and works. And it's a very, very basic, very simple sort of design, right? You have one motor moving X back and forth, one motor moving Y back and forth, and two motors on the outside moving Z up and down. There is a fifth motor in here. You can kind of see it's this unit right here. This is the motor that pulls the plastic in. So inside this unit, you can't see it. There's a little knurled knob, has a knob with teeth on it attached to the motor. And its whole point is to grab on to the plastic and feed it into the hot end. Okay, so it's this, oh, you can see it right there. You can actually see it on the screen. It's pretty neat. This hot end here. Now, if you can see it a lot closer, you would notice that it's actually the exact same sort of thing as I knock things around in my workshop, the glue gun too. It's the exact same idea. Glue gun is the same sort of principle as a 3D printer, where a glue gun, you pull a trigger, and that trigger pushes your glue gun stick into the hot end. It's the exact same sort of thing with this motor. This motor turns and it pushes this filament, this plastic, this PLA, polylactic acid, into this hot end. And when it hits that hot end, it liquefies and it comes out at a very specified, very well-known rate and speed and flow, move so far. And using all that information and a lot of math, the G code can take that plastic and control your 3D printer so that it prints out the object that you designed. So I saved that little axle holder file that we created real quick to this SD card. I can throw it in there. And with my 3D printer, like I said, it's fairly simple. So long as everything's all designed well. Mine's got this nice touch screen. We hit print. We can specify what we want to print, and now it's heating up. It's going to take a little bit to heat up. We don't have too much time left. They'll probably start working before our 45 minutes is up. But while we're waiting for that, I just want to talk a little bit about the different kinds of plastic that you can 3D print with, or the different kinds of materials, because it's not just plastic anymore. Polylactic acid, PLA, like I said, for industrial purposes comes from corn, and so they turn that corn, the sugar, the dextrose from the corn into this plastic. They extrude it, so they roll it out really small to very specific, very tight specifications, and then they spin it up onto a spool. They add different elements to it to change the color. So you can order filament in just about every color imaginable. There's even like shinier materials, even glow in the dark. There's glow in the dark 3D printing plastic as well too. PLA is very flexible, has a lot of give, a lot of bend to it. It's fairly inexpensive because it's coming from corn, and we're really good at making corn. It's good enough for a lot of purposes. It melts at around 200 to 220 degrees Celsius. Yeah, and so it's something that this hot end and this 3D printer can use fairly well and fairly easily. Another very popular material, ABS, acrylonitrile butadiene styrene. It's that same stuff that's in your drain pipe under your sink. The black plastic tube is ABS. Is another very popular, another very inexpensive plastic that people use with 3D printers. It is a little bit more rigid and stable and harder than PLA. So it has slightly better dimensional properties. And it's also fairly chemical resistant to a lot of material. Like I said, ABS is in your drain pipe, and you fire lots of things down the drain every day. So it can hold up to a lot of stuff. The only major thing that you got to be concerned about is nail polish remover. Oh gosh, what is that? Can't remember what it's called. The chemical is called off the top of my head right now. I'm having a senior moment. But yeah, nail polish remover can actually melt ABS. So that's really the only major thing that you'd be concerned about with it. Another popular one, PETG, polyethylene terephthalate. That one is the food safe one. That is the one that is FDA approved. So you could 3D print forks and spoons or sporks, or things that are going to be in contact with food. And this plastic is FDA certified. So again, it's another very popular one. Another popular one, TPU, thermoplastic polyurethane. This one is flexible, soft, squishy. You can use it to make tires. It's a very popular thing to make with it. But all sorts of things. A lot of things that have interaction with the human body, like you could make like an earpiece that goes inside your ear using this stuff. So yeah, so those are the major plastics. There's all sorts of other random exotic materials that people have got to work with 3D printers. Wood fibers is another popular one. So it's basically plastic with wood fibers in it. I think it's about 60% wood fibers and 40% plastic, and it retains a lot of the same properties or similar properties as wood. So like I said before, you could sand it, you can stain it different colors as well too, and so it has very much a look and feel of wood. And that one isn't terribly expensive. Here was my 3D printer. This is self-calibrating before it starts printing. Other popular ones, or common ones now, metals. There's lots of metals that they've figured out how to get to work with 3D printers. Now, again, it's just 60% metal and then 40% of plastic, so that metal can flow through your 3D printer head. So it's materials like copper, brass, and steel you can 3D print with now as well too, and you can polish them. You can make them look all shiny and nice and fun. They're definitely not as strong as solid steel or as solid copper or as solid brass, but they retain a lot of the appearance of those materials. So again, you can polish them and shine them up. So right now, that's it from materials. 3D printer, it's just starting to print. So it does a little bit of a calibration. It moves everything to its most extreme, so it knows where it's starting from. It's starting from 0, and then it starts printing. So right now it's printing a little bit. It's either a skirt or a brim, and that is the axle that we designed. Didn't take very long whatsoever. I yammered on quite a bit, but managed to actually put together something that could be 3D printed and you guys could see going. So basically, this is all it does now for the next 6 hours until it's done. When it finishes, the head will lift up and the project will slide forward and everything will turn off. The bed will cool. Usually with your 3D print, you just let it sit there. You let it cool and the print can pop off usually fairly quickly, because once the whole project is cooled, it kind of releases on its own off the printing bed, the main surface that it's printing on. And yeah, that's it. So right now, all it's doing is it's drawing the first layer, just one little thin strand of plastic at a time. Once it's finished drawing that entire first layer, the Z-axis will lift it up, I believe 0.2 millimeters, and I'll draw another one. And then once it's done drawing that second layer, it goes up again another 0.2 millimeters, and then draws that third layer, and it keeps going on and on and on until it's done. So that's it, I believe, for the 3D printing stream. I don't think I have comments. I don't think I had any comments or questions. That's more than fine. If you have any comments or questions, my name again is James. I am a programmer for Waterloo Public Library. My email address, let's throw that up. I didn't make a banner for that, but I can do that real quick. If you do have any questions regarding 3D printing, feel free to give me a shout. I'm always more than happy to talk. My email address is jgertz@wpl.ca. And that's it. So thanks again for those of you who showed up. And next week I have another one. I'm doing another Maketastic program. Should sell that one a little bit. I'm going to be doing a bit of an introductory blacksmithing or introduction to blacksmithing program. Something I got into a couple of years ago through some connections at Quartz Lab and a course that was being offered. It's a lot of fun. And hopefully maybe you can come back next week and see me hammer some really hot metal. So that's it. Thanks again. Bye. End broadcast.